sample T and G test, they are very similar. The only difference is only difference is when we do the G test. The reason we can do the G test because we know the population mean score. Because we know the population mean and standard deviation. Okay, remember how do we get G? How do we get G?
Z.
Yeah, how do we get G? How do we get G? We have two G, right? One is from the raw score, one is from the mean, right? And then let's subtract what? Let's subtract this, right? So you know that no matter which one, we know mu. Mu is stand for the mean score from population, right? And then how do we divide here?
Standard error.
With which one? You say standard error for
On the
which
bottom.
one? Right?
Yep.
And then here we divide by what? Right? And then no matter what, we all have this. That means we know the standard deviation from population. Okay, but when we do the one sample T, then you no longer know this. Instead, if we don't know this, then we have to deal with this. S. Okay, if we don't know this one, we have to handle this one. But they both stand for standard deviation. Okay, and do you remember when we calculate the standard deviation way back to chapter 4, and we have the formula? One is for this, one is for this. See, anybody remember that formula?
I don't remember.
Okay, what's this one and what's this one?
The formula for standard deviation
Yeah.
for population.
Mm-hmm.
The square root of EX squared.
This one, right?
Yes. Minus EX squared divided by N. And then all divided by N.
Which one is n minus 1? This one, no, right? This one like this. And then n actually had to be bigger n, right? Because it's a population, right? Right? And then what's different between that one and that one? So if we put s, so small s, that means from sample.
It's just small n's and then n minus 1 at the
Yeah.
bottom.
The only difference is, so these all the same. And then here. Right? The only difference is minus 1. Okay, so then when you see S, okay, when you see S, your calculation will be using this. Okay, when you see this, your calculation will be this. So then, in the question, if I give you S, you know you need to do T test. If I give you this, you know you need to do G test.
Okay. Easy again. If she gives you S.
If in the information, the question I say you have mean equal what, and then this equal what, or I say you have mean equal what, and then this equal what. The symbol will tell you, hey, I'm looking for Z test. Hey, I'm looking for T test. Okay, so that is, and remember last time when we do this, you're looking for this. Remember? When you are calculate G score, when you use standard error, when you use standard deviation, depend on do I give you X or I give you N. That's clue there. Okay, so you have to learn. In psychology, they have a term called stimulus generalization, and then stimulus discrimination. Anybody remember that term from your psychology class? Generalization means you learn how to respond to a stimulus, right? And the first step, you learn, you just apply. Whatever it looks like, apply the same way. And that can be a good step to start to learn. But after you learn enough, then you need to learn discrimination. Say, this asks for this asks for this, right? Because actually, I didn't tell you anything about the map. Yeah, I will tell you about statistical map soon when we get there. When you're doing statistics, just think about you are going to airport. You are going to different country. If you are going to different country, you need to take a different airplane. If you want to take different airplane, you have to go to different terminal. If you go to different terminal, then you need to go to different gate. Okay? So for example, you want to go to this country, okay? You need to go to the terminal with standard error. Then you can get the right flight, go to the right country. Okay? That makes sense? If you want to go to this country, even the two countries look similar, like I'm from Taiwan. Sometimes people say, oh, you're from Thailand. I said, no, Taiwan, not Thailand. Okay, then they sound similar, but they are different. Okay, so for this one, okay, again, for this one, what is the clue?
For what one?
Which one to remind you, you need to use standard deviation or standard error?
Whether you know X or M.
Yeah, whether X is raw score, M is the mean score from sample, right? So that's why our chapter called the sample distribution of means, right? That's what we learn, right? Okay, so then this time you need to learn, do I give you that symbol or this symbol? Okay, actually the step pretty much the same. The step I'm going to tell you, and then also one thing different is you use table 2 this time, not table 1. Use table 1, suppose already for several chapters. That's already your friends. Now you need to make a new friend from chapter 2. No, table 2. And only one page. And actually, it's not too hard. Okay? So that is a couple difference. If you get this difference, okay, you get this difference, you already have a very good starting point. Okay? That clear? Okay. As a step, when you do the statistics, okay, actually you are a philosopher. You are not really a statistician. You are not just calculate the number. You need in the position decide where I need to do, what I need to do to get the things I want. Okay, so that's why I keep giving you this kind of concept. So if you have a good concept, okay, then you will make the right decision, you'll go to the right spot. Okay? Now, we are ready for next minute. Today I need to say next second, or still minute, or 10 minutes, or next hour. Okay, let's say next step about that. Okay. Then, let me put my And actually, I teach research design for undergraduate. I wish I can teach them statistics and research design same time. Because whatever I say, they confuse. And I don't have time to give them enough information. I assume they already finished their statistics class. But then they already return back to the teacher. Totally. So when they come back to my class, they kind of, And then, but I have no time to give them all. I try, but then still a little bit gap there. Okay, but anyway, here. Okay, see, I give you all the formula. Okay, G test, we call G statistic, T statistic. Okay, so see, we still have this standard error. We have standard error. And the reason I put this one, the book don't have this one in this chapter. I bring back from our previous chapter. So the one we just talked about it. The one Adria just give us the information is here. Okay? So actually this one should be first, so you know how to calculate your standard deviation. Okay? And then you know how to calculate standard error. Then you see G of 10 and T of 10, they are the same. Okay. And then one more thing here, actually, this part we call standard sum of square. Okay, so if you see the last formula here, sometimes the homework give you SS. So if they give you SS, that means they already take care of this part for you. This part. Okay. Inside this part, called SS. Okay. Inside the part called sum of square. But make sure you know the sum of squares inside the square root. So you need the square root. You need to do the square root, okay? How do you feel about formula right now? When you see formula, do you feel uncomfortable or you feel familiar? You feel that's a friend? What do you relate? How do your association with formula? Once you get to know them, they are not too horrible. Okay, they are not too horrible. And we use the same formula again. So the most formula you use actually is standard deviation, because when we compare means, we need a standard deviation, we need a mean score. That's two things. We don't use range that much. We don't use interquartile range. We don't use that much. And we don't use mode. We don't use median that much. The only two, we say if this all the number is actor, they got a full-time job. They can start to continue to acting on our stage up to when we get to our chi-square. Okay. So sounds good? Okay, so what's the difference between T and G? What's the difference between T and G? G is you handle population, okay, most of the time. And then if you know the standard deviation from population, use the G score. Quite often, we don't have lectures to know the standard deviation from the population, right? You maybe know mean. You will know mean, but you don't know standard deviation. So then that's why you need to have a SM. Okay? Okay. So then the T distribution, okay, here, they also give you the different here, okay. G distribution, usually, they are normal distribution curve. G, most of the time, actually, all the time, they are normal distribution because they are from population. So they're supposed to be normal distribution. Okay, so their curve don't change. But then D distribution, even they like symmetric. Okay, but you can see sometimes if their number is smaller, their normal distribution a little bit flat. Okay, if their distribution is more, degree of freedom is more, even infinity is the best, then you see their distribution is a little bit, a better shape. So you can see their distribution change. Okay. When you see DF, everybody still remember what DF stands for? Degree of freedom. And then everybody remember my cookie example, right? Cookie, right? You remember I said cookie? Right? You have 5 people. How many degree freedom? If you have 5 people, 4. Because I said that, right? I said a cookie, right? Do I give you the cookie example?
Yes.
Right? I say, Andrea, bring 10 cookies, right? And then each of you, the first 5 students can get a cookie, but the first one, second one, third one, fourth one can say how many cookies you want. The number 5, when he or she walk in, I just give that student the rest of cookie. And even the student say, I don't need a cookie. I say, well, you have no choice, right? So if we see degree of freedom 5, what is the N? What's the N? 6. You see 15, what's the N? 16. Okay, you plus 1, okay, for one group. If you have 2 groups, you plus 2. Okay, so now this is a table from your book. Okay, this time I think I did better job, right? I try to find I can take a better job of the table. Okay, so how do you read this table? To read this table, and actually this from your page, after G table. You finish all the G table, keep going. Yeah. It should be, no. You are over. Table 2, should be called table 2. Hopefully you have the table. Yeah. Okay. There, right? Everybody?
There, don't worry.
Hopefully that don't pick up. There, right? Yeah. Okay, so you see this side. This is called degree freedom. This is called degree freedom. So the first thing, before you know the critical value, okay, you need to know degree freedom. Okay, and then you can see actually only get to 60, right? And then 120, and then infinity. So if you want any number between 60 to 119, you go by 60. You go by the a little bit lower number to be more conservative. Okay, so if you have 70A, you still go by 60. Okay, so let's do some practice there so we can do together. Okay, so for example, this one degree freedom 11, right? So it's 11. Okay, if there are 11, do you see this line? Let me draw the line. Right? That's my degree of freedom 11. Right? Now, alpha level 0.01. Okay, 0.01, you have 0.01 where? Here and then here. But we need to see, are they 2 tail or 1 tail? So there are 2 tail, and then 0.01. So see, this one is 2 tail, that one is 1 tail. So if 0.01 for 2 tail actually is here. Oh. Right? Right? Okay, and then 11. Okay, 11.01. So is your T critical?
3.106.
That one, right? 3.106. Okay, how about 80? We don't have 80, right? So you go by 60. Okay, we don't have 80, so you go by 60. Okay, 60. Okay, and then it's a two-tail, and it's 0.05. So 0.05 and two-tail, 0.05. So you go down, 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 and it's go by 60. So we should have answer what? 2.000, right? Got it? Okay, are you able to find your table? Okay. Now, one tail, 24. Okay, let's see, 24. We do have 24. Okay, so 24 is here. Okay, and then we are looking for one tail, so it's on the top, and it's 0.05. 0.05 is here. Okay, and we say 24. 24 and 0.05. Do I have a 1.711? Right? Wow. Okay, how about 0.01? Also 24. 0.01, 24, and one tail. So should be here, to 24. So it looks like 2.492, right? 2.492. Okay, how about 0.05, one tail, 42. Okay, we don't have 42. So you go by 40. Okay, we don't have 42, so you go by 40. 40, and then one tail and 0.05. One tail and 0.05. One tail, 0.05. 0.05 here, one tail. 40, so still here. One tail, 0.05. I think I got 1.684, right? Okay. Can somebody tell us about two tail, 0.05? Two tail,
42.
0.05.
2.021.
Two tail, 0.05. You say what? 40. 40. 2.021? Okay. Okay, 19. We do have 19. And then 0.01, 19. 0.01. 19, 0.01. Two tail. Two tail. Two tail. Here, right? Is that this one? 2.861? Okay, now this is 0.221. 0.221, two tail. 0.221, two tail is here, right? And then the number is 19. Okay, 19 here. 3.883, right?
Yep.
Okay. So make sure you get to the right tail, right number. So all the numbers have to be right to get the right answer. Okay, so now after you know this, now your decision, are you going to reject? Are you going to fail to reject? Okay, now look at here, and you tell me. That's the same concept as 1 we're doing the retest.
Yes.
Which one is yes? This one is yes?
No.
Because what?
Because T crit is lower than U.
This one over into the rejection area. How about this one?
No.
No. So this one's smaller. Okay, how about number 3? Hmm? Yes. Right, this number had to be bigger than this number. Right? Okay, so how about this one? No. This one? This one? Yes. This one? No. This one? Yes. And this one? No. Wow. I don't know what you are worried about. You are pretty good. You are pretty good. Right? You need to have the confidence. Okay. So this stuff, let's see. Actually here I have the answer. I try to find and put the answer. So you have all the answer there, and then we already have the answer. Okay, just match. Yeah. YN, 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 YN. Yeah. Okay. So this equation. When we do the step, we are going to use this equation. This is from your book. Okay. So if you look at this equation, how do you know you are going to do t-test or z-test? Look at all the information you get it. You got a mean, right? They give you the mean of population, right? And then you give the N, right? So then they say the standard test critical thinking is this, okay? Then just stop here. Before we even go to step, you already have a concept about how to set a hypothesis, right? Similar, okay? See how far we can get it. We can beat our PowerPoint, okay? So the first step, if I want to do the hypothesis, right? Remember HO and H1, right? And last time we used Z. This time, I don't think we can use Z because we don't know the standard deviation from population. They give you SS, okay? They give you this, okay? They give you N, okay? Think about SS. Remember the SS, I have the formula. SS equal the inside part of standard deviation, right? Okay, so then we want to know, and then we are testing two-tail. So you know, you have to write T. T. Don't write Z. Okay, that also can be, you know, your type error, like, because you are so used for Z, so when you are typing, and also watch your computer. Because when you type T, they tend to turn your T to capital T. This one should be student T. Remember we calculated T already, T score. Remember we have those 50 plus what? 10 G. The T score, you transfer G score to the standard score called T. Now we are working on T. They are different T. This is a capital T, that's student T. But your Word document don't know. So for example, when I type this one, if I use the PowerPoint, they only can type the capital word. They give me capital T. So I need to work so hard to transfer back, okay? So your computer, especially if you put T as a first word, they turn to capital T. Please go back to change that, okay? So now T, and we say we are doing two tail, so you have to be equal and what? Equal and unequal, right? Right? Two tail. If one tail will be greater and smaller, but two tail have to be equal and equal. Okay? And equal and equal, then the number there have to use which number? We are equal and equal to whom? This number. The mu. Mu, okay? So be 53 and 53. That's our first step. Okay? So, and then my alpha level is 0.05. Okay, that is the second step. You need to find your T critical. Okay? So that's your first step. And please correct me if you see I'm doing something wrong. Just because I stand here, I'm not guarantee every word I say is correct. Okay? My mind can be speed up. Okay, so you can stop me too. Okay? Now, what's the next step? So that's step one. That's step one.
You have to figure out T critical.
Yes. We need to look at alpha level and T critical.
It's two
Okay.
tails, so you have to divide 0.05 by 2.
Now, in the table you just looked at, this table, okay, because Andrea just talked about divide by 2. Okay, now for this table, you need to divide. The table they set up,
Probably not, because I already set it up that way, right?
they already set up this, don't divide. This called stimulus discrimination, okay? You divide by 2 because that when you do your G test, G critical, that's the way they set up for the table. So you need to divide by 2 so you can find the right area, right? Here they didn't ask you, they just asked you, they already give you 2 tail, they already divide for you already. So 2 tail, 1 tail. Don't, divide. Okay? Don't divide. Okay? If you divide, then you get the wrong number. Okay, so if we are alpha level 0.05, okay, and then our N is what? What's our N? 87, right? So if N equal 87, what's the degree of freedom? 86, right? Okay, then remember they don't have 86, right? So what is your T critical? Let's go back to our, okay, so back, remember the information is 2 tail. Let's write down here. So when we go to the table, we know where are we looking for. 2 tail, 86, okay, 0.05. Right, so you back to the table. Okay, go back to this table. I know the background is kind of strange. Okay, but anyway, so 2 tail, go to 2 tail, go to 87. We don't have 87, so we go to 60. You go to 60, okay? You go to 60, and then we are looking for 0.05. 60.05, 60, and 0.05. 2 tail is here, right? Here. Okay. So what is our T critical? Huh? Positive, negative, yes. positive, negative, right? Minus, plus, minus, okay? Point, at 2 point, 0, 0, 0. Yes?
Why is it positive, negative?
Because 2 tail.
And if it was one,
If 1 tail, then depend on which side. If you are left side, that will be negative. If you are positive side, it will be positive. Okay? But 2 tail, that means they can be either better or worse. 2 tail. Okay, and again, they don't give you that positive negative number. You have to put them yourself. So thank you for reminding me. If you don't say it, maybe already forget about it. Okay, so we got this. Okay, so let's go back. Okay, so then here, actually, we already here number. Okay, we are correct here. Okay, then the second step, all that is this. So far, so good. Okay, then your third step, we have to calculate. Okay, and since they already give you SS, they didn't give you raw score. If you got raw score, then you have to start from scratch. Okay, use that sum of S squared minus sum of S parentheses squared divided by N and then divide by N minus 1 square root, right? They already give to you. Then save you a lot of energy. Okay, so they give you 6013, right? Everybody remember the number, right? Okay, then they give you 87 minus 1. Okay, then you square root, get 8.36. Okay, so now this just standard deviation. We are not done yet, right? So after you get it, what's the next step? What's the next step after you get standard deviation?
Find standard error.
Standard error. How?
You take S divided by square root of
Yeah. 8.36 divided by square root of N. Okay? So you get 0.90. And still not done yet. Right now we need to get T-score. Okay, T-score pretty much same as G-score. Okay? See? Did you see? They are so similar. They are so similar. They are M subtract mu divided by SM. Only difference between G and T is this part. Okay? So then you divide. 55, that's the score. You got it from your own sample. Subtract the population mean, 53. Divide by 0.9. Okay? 0.9. Okay? This number, they cannot talk. So when you put the wrong number there, they cannot say, don't take me, don't take me. They will just whatever you take it. So then if you put the wrong number, at least you go back and look at. Okay, so when you finish, go back and look at. Okay? It's so interesting. You guys all use pencil, right? Before I came to America, I already forget about pencil. Because in my country, people don't use pencil. Then when I come to America, because I always worry I maybe do something wrong, so I always have pencil. So now pencil is my friend. So if you use pencil, when you finish, don't just say done. Okay, before you submit, sit down and go through one more time to see, is number, any number suspicious? Then you may find, maybe you put the wrong number there. Okay, so everybody good so far? So then you got it. Okay, now, when you know 55 is bigger than 53, so you got a positive. Okay, positive. Okay, then if you put positive there, it's easier for you to do your comparison. Okay, and okay, so now let's look at here. Okay, so we set up 2, but we got 2.1. We got 2.22, right? We got 2.22, so that we know, right? It's here. 2.22 here. So they are inside the rejection area. Right? So here you pretty much say student told by this, and reject HO. We reject HO. We reject this one. Right? And then we say 86. Inside this 86 is degree of freedom. Okay? Then this one, sometimes students have trouble for less and greater. Okay, now, why we say less than 0.05? Why? Why is say less? You know why it's less? Because look at this area, right? We set up this area is from here to here, right? But then now we are from here to here. You got a small portion. That's why you are less. Okay, so your T of 10 have to be bigger, but then because they are bigger, make your P smaller. Because you are so good, so you only a few people can compete with you. The higher number you got, you are more lonely, you are more lonesome. Okay, that's why your proportion becomes smaller. Okay, so make sure if you reject, have to be this sign, smaller. If you are failed to reject, then this one. Okay? Okay? So it's different. You have to be bigger for obtain score, but then they make your probability become smaller. Okay? Okay? So now the next step the same as the one. What's the next step? What do we do in this score after we get conclusion and we got rejection? What do? We test what? Effect size. Effect size. Okay, Cohen D. Okay. Same thing here, okay? And similar formula like last time, again, the standard deviation S, okay? Then this one, we have 55, subtract 53, and then this time, go back to divide by standard deviation. Okay, then you get 0.24. And you remember that the chart, okay? If they are smaller than, they are 0.24, they are small effect. So then you say small effect. Right? So easy. Okay, so now this is from your turn. Okay, this sum actually is no longer to tell. So we have to be very, very careful, okay? How do you know it's not to tell? Because they didn't say different, they say improve. Or if they say decrease or they say increase, that means they are looking for one direction. Okay, so this one, you play golf. Okay, so the mean score for golfer at the county of golf course is mu equal 83. Okay, the manager wonder if posting a red flag at other sides will improve score. Okay? After posting the flag at all such sites, she obtained a random sample 25, so you know N is 25. Go for who mean was 81 with SS 788. Do the data indicate that flag improve golfer? And they give a note. Low score reflect better performance. So you say lower is better. Okay. So if you know lower is better, then you know where the hypothesis should go. What hypothesis should go? If you are confused, always write the research hypothesis first. So then your non-hypothesis will be object. Okay, so lower is better. Oh, I said mu, should be T. Last time, did I say mu or I say T?
You said T.
But are we supposed to say mu?
I don't know.
And nobody stopped me?
Just trying to keep up, man.
Yeah, me, sorry, me. Erase your notes and go back. Say mu. See, my hand remember mu, my mind say T. So this time I put mu. Okay. Yeah, go back your notes and write down mu. Okay. Okay, so now for this one. So we said lower is better. Okay, so see here. Look at here. Lower is better. So I say, I want them to be lower than 83. Right, so this is what you want. Then after you write this, you go back to write null hypothesis. Okay, and then now I have to take care of the rest of them. So need to be greater and equal. So when you write hypothesis, you also make sure who take care of equal sign. Most of the time, actually, should be HO. If this one say higher is better, then this be greater, and then it be less than equal. Okay, so then for this, your T critical have to be positive or negative. Because remember lower is better, so they are go to which side? Left side, right? So the T score, T critical should be positive or negative, negative. Okay? Make sure you remember, okay? If you put less, then have to be negative. Okay? Less have to be negative. Okay? Okay, so what's our second step? Okay. So your alpha level, and also make sure you're aware, put down the right alpha. So in my homework, I mean, some of you already finished, you see some part have 0.05, some part 0.01, okay? And so make sure you follow the right alpha level, okay? Then you calculate the degree of freedom, so 25 minus 1 is 24, okay? So when we go back to the table 2, we find out they don't give you negative, they just say 1.711. But you put negative yourself. So even before you are looking for, you just put negative sign there to wait. So put a negative sign first. But make sure you remember, if you give me the probability, no negative sign. No negative sign, whatever for probability, proportion. There's no such thing called negative proportion. Okay? But for value, yes. Okay? Then you got a T critical negative 1.711. Okay? So far so good? Okay. Then you calculate, you divide by standard error, you get your standard error is 1.146. And then you got your T of 10, 1.75. Okay, so now let's look at here. So 1.711 is here, negative 1.711. And now you got a negative 1.715. Is it here or here? 1.715 is here or here? Here, right? Right? Because 0 is here. So negative 1, negative 2, negative, this number. Sometimes when students get to negative number, they're confused. Okay, so it's here. So is this, are we going to reject or fail to reject? Are we reject or fail to reject? In here, right? They are in rejection area, right? So before I move to next slide, our decision is reject HO, right? And then what? What's our T? What's degree of freedom? 24 equal negative 1.75, right? And we reject. So when you reject, how do you write P? Less or greater?
Greater, no, less.
Less.
Less. This piece be smaller, right? So less than. And then remember, write down the right alpha level. Right? Yes?
How do you get 5.73 for S?
You got what?
How do you get 5.73 for S?
You put the for N?
Yeah.
Oh, you mean You mean this one?
Yeah.
That's for S, right?
It's the square root of 20.
That's 5, right? Do I wrong? Am I wrong?
I don't know if I did at all, so I don't know.
This S is from our, I think I missed one. Here, okay,
Oh.
here, sorry. That's another, okay. 5.73 is S. Okay? And you divide by square root of N. So you got this number, 1.146. Right? Okay, so we got this, so we reject. Then when we reject, what do we do next?
The effect.
Effect size, right?
Yeah.
So we use D, right? So how do you do D? You will have a 80, what is the mean score? 81 minus 83 divided by 5.73,
Yeah.
right?
Yeah.
Okay, now, even this looks like negative, but actually it's absolute value. So still positive, right? So it should be 2 divided by 5.73. Okay. So effect size always positive because you use absolute value, to eliminate the negative number to appear. Okay, so let me go here. Okay. So then that's what we do, right? Right? And my negative sign here. Okay, negative 1.75, and then we divide 0.35. So this is small effect.
So why do we reject HO?
Why we reject? Because your T could obtain get into rejection area. Because we set out 1.711 negative, and your 1.75 actually is into the area. Okay, make sure that's most important. As a researcher, if you make the wrong decision, that's the biggest mistake you make. You take the whole world to the different direction.
The whole world.
Yeah, whole world. Because people look at your research, and if they are supposed to reject and you fail to reject, okay? And then remember we talk about type 1 and type 2 error. And this not, if you make wrong decision, that's not even just type 1, type 2 error, because the whole result. So then that's why when I grading your homework, if I find those mistakes can be more serious, then I tend to more serious.
Yeah.
You know, because I just think about we are handle the number, so we have to be very careful with the numbers.
Great.
Okay. Okay. And then, yeah, why I have a one more time. I didn't done that. Why? Okay, and then let's start for this chapter.
Good. Yeah, we're
Yeah.
done.
And then we are going to do SPSS. See? Not too hard. Okay. Only thing you have to be careful is to decide are they using Z or using T. Okay. And then make sure you're aware you have to get to standard error. Okay? Good. Okay, let's take that 2 or 3 minutes break and we can prepare for the SPSS. So that's done for our chapter lecture.
We can take a break.